The braking time of a car increases as the velocity of the car increases. This is because a larger velocity causes a larger braking distance. A fast velocity causes you to cover significantly more ground per second than you would cover if you were maintaining a small velocity. The equation that accurately relates the effective velocity on braking distance is distance equals velocity squared divided by -2 times acceleration. V is the velocity, and then acceleration in this instance is negative since we're slowing down.
Vehicles vary in braking distance for a few reasons. Reason number one being the weight of a vehicle affects the braking distance. So a smaller vehicle will come to a complete stop before a larger vehicle will. So for instance, sedans will come to a complete stop before SUVs will. Reason number two being that the brakes of a vehicle will affect its braking distance. So cars with newer brakes tend to stop sooner than vehicles with older brakes. Reason number three being that the road conditions affect the braking distance. So if it's raining outside, then the car is going to have a harder time braking than if it was dry outside.
There's three main safety risks that come with speeding. Number one, it causes you to react slower than needed to assess certain driving threats. Like if an animal runs into your path on the road and you're going super fast, you might not have the reaction time necessary to avoid it. Number two, it causes your stopping distance to increase significantly. This can be dangerous in regards to intersections. If you're going too fast for the speed limit on a certain intersection on a road, you have to stop, you might not be able to stop in a safe manner, assuming the light turns red. And then the third main safety risk is, speeding can kill you. If you go too fast, you can lose control of your car, you could hit someone else.
Distance required to stop is proportional to the square of the speed. If you go double the speed limit, it's 4 times greater to stop. If you go triple the speed limit, it's 9 times greater to stop.
The factors that play a role in yellow light intersections are yellow light time, width of intersection, speed of vehicle, response time, and negative acceleration. The bigger the intersection, the bigger the go and stop zone must be, because the stop and go zone must equal out to how big the intersection is. With the width of an intersection, the yellow light time is going to be longer. With the speed of the car, the yellow light time will be easier to make with how fast it is going. Time does not affect the stop zone. The slower you're going, the easier it would be to stop, and the longer the yellow light time, the easier it is to make it through the intersection.
This is Campground and 155. Campground is a 45-mile-an-hour road and 155 is 55 miles per hour. The yellow light time for this intersection is approximately 4.8 seconds. This is Eagles Landing Parkway and 42. 42 is 55 miles per hour and Eagles Landing Parkway is 45 miles per hour.
The factors that change how I react are the speed of the road, what is the speed limit, is it slow or is it fast? The condition of the road, is the road wet, dry, or icy, or other distractions such as a busy intersection or a busy road. The speed